Welcome to AI for Data. Today we're going to find out how good is GPT-4 at answering SQL interview questions. Now, I've done dozens of interviews with data analysts, data scientists, and data engineers and asked them lots of SQL questions. So we're going to figure out today, how good is AI? First, let's set the intent and say you are a data engineer interviewee who gives clear and short answers to data engineering, SQL, and other database questions. Let's start with some easy ones. Let's start with a basic one that requires an actual query. If you have a table, Postmates orders, how would you calculate how many customers place an order and what is the average order amount? It starts with an assumption about customer ID and order amount, calculates count distinct, and does this in the same query. Perfect. Okay. How about a question about joins? So let's see if it understands and can describe what a join is. Okay, it knows what an inner join is and what a left join is. All right, we're 10 out of 10 so far. Let's do one that's a little bit harder, but let's say it's still an easy one. Here's a question about triangles. So I'm telling it that, imagine we have a triangles table, and it has A, B, and C for the lengths of the object, and I want it to tell me, for each triangle, for each row, what kind of triangle is it. All right, here we go. A, B, C, and we're going to use a case statement. Not a triangle if, okay, yep, looks good. Yeah. That's an interesting way to do it, but sure. Okay, great. So we have 10 out of 10 for easy questions. Let's move on to medium. Let's do the classic binary tree question. You're given a table BST with two columns N and P. N represents the value of a node, and P is the parent. Write a query to find the node type of the parent tree, ordered by the value of the node. This one's maybe actually bordering on hard. Let's see if it can solve it. Let's see, case. Yep. It's doing the, great. Okay, so here's something an interviewer might follow up with, because not all languages love it when you do the select inside of the query. So can you rewrite this with the join instead of a nested query? Amazing. So here we can see that it's not just prepped questions that it can answer, it can do follow-ups quite adeptly. Here we go. Let's make sure that it's reasonable. Obviously, I can't check these exactly, but they look good. Interesting. Okay. Let's move on to another one. This is going to be a big one, so I'll walk us through it. But let's see how much text it can input. You're given two tables, students and grades. Students contain three columns, ID, names, and marks. Grades contain grade, min mark, and max mark. Katie gives Eve a task to generate a report containing three columns, name, grade, and mark. Katie doesn't want the names of the students who received a grade lower than 8. The report must be in descending order by grade, i.e. higher grades are entered first. If there's more than one student of the same grade assigned to them, order these particular students by their name. Finally, if a grade is lower than 8, use null as their name and list them by their grades in descending order. If there is more than one student with the same grade assigned to them, order those particular students by their marks in descending order. Write a query to help Eve. So here we're testing to see whether it can handle rather complex sets of instructions. Not complex in their mathematics, but just complex in that there's a lot of things to cover. Oh no, I accidentally asked two questions. Well, all right, let's see what happens. Okay, so for the first one, when grade is 8, less than null, great. From students, join. Okay, so it looks like I answered the first one correctly, and then it correctly said it's going to do the next one. Okay, so we can just grade this one too. So I asked, when you're given a table, your functions containing two columns x and y. So this is a classic SQL interview question. two pairs are symmetric if x1 equals y2 and y2 equals x1. Write a query to output all such symmetric pairs in ascending order by the value of x. Amazing. Okay, let's move on to hard. I'm going to try and input some examples. The formatting won't look great, but let's see how it can answer it. So imagine we have this, and again, sorry for the formatting, but visit date is the primary key. Each row of this table contains the visit date and the visit ID to the stadium with a number of people during each visit. No two rows will have the same visit date, and as the ID increases, the dates increase as well. Write a SQL query to display the records with 3 or more rows with consecutive IDs, and the number of people is greater than 100 for each. Return the table ordered by visit date and ascending order. Okay, so here we're doing self-join, so it has to make sure that S1 is S2 minus 1. This is ID minus 1. This visit ID. I think consecutive IDs. Right? Yeah. Okay. This looks like it checks out. I'd have to run it to be sure, but it's kind of a little tricky. It looks like it's not that hard, but it's also something that you could easily mess up with. Okay. Let's do another one. This one will take 2 tables, employees with ID, name, salary, and department ID, and then department with ID and name. And the executives are interested in seeing who earns the most money in each of the departments. A high earner in the department is an employee who has a salary and the top 3 unique salaries for the department. Write a SQL query to find the employees who are the high earners in each department and return the result table in any order. Okay, so so we're doing the subquery trick again. It's not a trick, but subquery of this again. I could ask the follow-up, but I don't need to because we already know they're doing it. And then we're doing a subquery on the where clause as well. Oh, interesting. Where is less than 3? Oh, that's cool. That's clever. Okay, this is great. This is more elegant than I would have written it. All right, let's do one more of these hard SQL questions, and we're going to move on to qualitative questions. Okay, you are given the following table containing historical employee salaries. Given the above table, can you ever write a SQL query to return the employees who have received at least 3 year-over-year raises based on the table's data? Okay, so I think I'd do this with a lag, but it looks like it's doing it with a self-join. That might be more efficient. I'm not sure. Let's ask it. Here we go. So it's perfectly capable of doing window functions, and it can translate things easily. Here we go. Lag salary 1 over, yep, here we go. Good. Then let's see if it knows which one's more performant. I actually don't know. I would assume that the inner join is, because window functions usually are not, but I don't really know. Great explanations, too. It's so funny. I think that's wrong, but ChatGPT is so correct that I'm actually think I would have thought that was wrong, but now I'm starting to doubt myself. Multiple self-joins. Well, okay, yeah, self-joins because you can have fanning problems and those. All right. All right, let's ask it a qualitative question. Can it handle that? Which ETLs have you worked with? Well, that would obviously disqualify them, but let's see the rest. Apache NiFi. interesting. Okay, this is great. So I've personally been asking ChatGPT about a lot of different ETL code, specifically a lot of DBT, and I happen to know that it is very capable of running DBT code, understanding complexities of it. I also have heard from other folks that are using Airflow. It knows a lot about those. So I could spend a lot of time digging into the specifics here and ask more questions about those, but I think we'll just say ChatGPT will absolutely demolish a data engineering interview. Or a data science interview, or a data analyst interview that's using SQL. So if you're running interviews now, and I may have to figure this out myself in the future, we're going to have to totally change the game, because I don't know how to ask questions like this anymore remotely. Thank you.